Hello, so let's get started with the calendar problems in this video. So the kind of problems we are after during the course of this video is this, something like this. What was the day of week on October 2nd, 1869? That coincidentally is birthday of Mahatma Gandhi, but that's another thing. The problems, when we are looking to solve the problems related to calendar, this is a very typical problem which is asked. That is, you have to find the day of week of a certain date. It could be any date. For instance, here it is 2nd October 1869. It could very well have been, say, 27th February 1989 or something like that. You must have often wondered that some people are able to solve these kinds of problem in a very easy manner and very quickly. And then they illustrate that there is some magic or some tricks around it using which you can do that. But we will not be going for the tricks. Instead, we will be following a step-by-step approach, and the result of which shall be a trick, our own very own trick to solve such kind of problems. So let's get started. Let's get started with the concepts which are involved to solve the problem like this. So to get started, first of all, let me illustrate some things. First thing is that 1st January AD, 1st January 1 AD was a Monday. That is January 1st, 1 AD. Immediately, as the calendar started from a Monday. Therefore, we must count days from Sunday. What this means is that since the first day was Monday, 0th day was Sunday, and hence first day Monday, second day Tuesday, likewise 7th day will be a Sunday. So whatever days we calculate should be with respect to Sunday. For instance, we say 10th day, 10th day of the year, then that is 10th day with respect to Sunday. That is 10th day of the year 1 AD will be 10th day with respect to Sunday, which will come out to be Wednesday. One more thing we have to keep in mind is that the year which we are in is an ongoing year. For instance, we are in year 2012 right now, and date today is 22nd September 2012. What this means is that 2011 years have passed and 2012 year is in progress. So start of 2012 means that 2012th year has started. It's not like the 2012 years are over and then we are counting on top of that. No, it's like 2011 years have finished and 2012th year is in progress. So we need to keep this in mind. Then one more thing is a leap year. Most of us, the most common knowledge which most of us have is that leap year comes once in every 4 years, which is right. But then we do miss some intricate details of the leap year. That is, yes, it does come once in 4 years, and hence, if we go right at the start, fourth year from the start, that is 4 AD, was a leap year, and similarly 8 AD, and so on and so forth. But then there is one very important fact which lots of us don't know. That is, if it is divisible by 100, it's not a leap year. That is, 100 AD was not a leap year. Not a leap year. Similarly, 200 AD was not a leap year. Why I am illustrating divisibility by 100 is that because 100 is anyways divisible by 4. So if you see 4, 8, 12 and keep going, you will find that 100 is one of the multiples of 4. It is divisible by 4. So by this calculation it should be a leap year. But then since it is divisible by 100, it is not a leap year. And on top of it, we have one more condition. That fine, if an year is divisible by 100, it is not a leap year. But If it's divisible by 400, then it is a leap year. For instance, 400 AD. This definitely is a leap year. 800 AD is again a leap year. On the other hand, say 900 AD is not a leap year because 900 is not divisible by 4. So 900 AD is not a leap year. Let me write R here. So this is how it goes. So yeah, it's little tricky to remember the concept of leap year, but then that is very important in the calendar calculations. Let's move to our next concept. This is the concept of extra days. Now this concept of extra days is single most important concept for solving all the calendar related problems. Let's see what it is. So we all know that day gets repeated after every 7th day. That is, if today is Monday, then 7th day from now, 14th day from now, 21st day from now, and 28th day from now will also be a Monday. Pretty simple. That is the concept of a week. Or we can directly say 28 by 7 equal to 4, which is a whole number. So 4 weeks. Now by same logic, 30th day from now, if today is a Monday, then 30th day from now will be 4 weeks and 2 days. So after 4 weeks we get a Monday, and 2 days further after that we get a Wednesday. So these two extra days, these 2 days, when I calculated 30th day from today, will be called extra days. So with starting day as Monday and 2 extra days, the 30th day will be a Wednesday. Let's move to the next concept. Yeah. Now another thing is pretty much known, that is a normal year has 365 days, which makes it 52 weeks in a year and 1 extra day, which is pretty clear because on dividing 365 by 7 we get 52 as my quotient and 1 as my remainder. So in an year there are 52 weeks and 1 extra day. Leap year has 366 days, and 366 by 7 will leave me with again a quotient of 52 and 2 as remainder this time. Okay, so this is about extra days in a leap year and a normal year. A leap year has 2 extra days and a normal year has 1 extra day. So before moving to the next concept, let me try to illustrate something. Say 1st January 1907 was a Tuesday. Say, I am not claiming it was, but let's say 1st January 1907 was a Tuesday. And since we are talking about 1907, which is not a leap year, this 1907 has 365 days. So as a result, 1st January 1908, 365 days have passed. That is, if I calculate the total number of days starting from 1907 to 1908 and compare the same date, 1st January, then 365 days have passed. That means 1 extra day, which would imply that if 1st January 1907 was Tuesday, then 1st January 1908 would be Wednesday. Wednesday. Okay. So now with this knowledge, let's move to the next concept. So the concept of rolling over of extra days can be summed up in these two problems, which say that what are the number of extra days in 4 years. For now, read it first 4 years, that is from 180 to 480. And what is the number of extra days in first 53 years? And the solution to these two problems can very well illustrate the concept of rolling over of extra days. So here it goes. What's the number of extra days in 4 years? We saw that in a normal year, which is a non-leap year, normal year or a non-leap year, we have one extra day, as discussed in the previous slide. In a leap year, 2 extra days. So in first 4 years, we have 3 normal years. That is first 4 years. We have 3 normal years and 1 leap year, which gives me 3 into 1 plus 1 into 2 equal to 5 extra days. So pretty simple. The answer for this is 5 extra days. But now let's come to number of extra days in 53 years. In 53 years, in first 53 years, we would realize that 480 was a leap year, 880 was a leap year, and similarly till 52 AD we had leap years. So this is 13 leap years, and hence 53 minus 13 equal to 40 normal years. Therefore, extra days is equal to 13 into 2, because 2 extra days in a leap year, plus 40 into 1, which is normal year, which gives me 66 days. But hang on, it is not 66 extra days. Instead, it is something else. That's where the concept of rolling over of extra days comes. So the way it works is that if you have less than 7 extra days, it's fine. But think that if you have, say, 7 extra days, then your 7th extra days comes back to the same day. For instance, if you are calculating 7 extra days from a Sunday, then 7th day from a Sunday is again a Sunday, and 8th day from a Sunday is again a Monday. So a first day from a Sunday, first day, 8th day are same. Therefore, 1, 8, 15, 22, all these days are same. So first, if it's 1 extra day, then also we will call it 1 day, and if it's 8 extra days, then also we will call it 1 extra days. Similarly, for 66 days, we'll do like this. 66 is something like this: 9 into 7, which is 63, plus 3. So it's not 66 days, but only 3 extra days. That is, after the count of 7, days get rolled over. That is, extra days get rolled over. So 66 days means 3 extra days. Similarly, for an exercise, say if I ask you to find 26 extra days, what does this imply? then you should be able to answer that 26 is equal to 3 into 7, because closest multiple of 7 is 21, plus 5. So this gives me 5 extra days. So 26 extra days maps to 5 extra days, just like 66 extra days had mapped to 3 extra days. So that's what the concept of rolling over of extra days is. Okay, so now let's do some problems on this extra days concept, and these problems are also part of your concept building. Let's see how. So they are asking what's the number of extra days in 100 years. So in 100 years, if I see 4 AD, 8 AD, like that, till 96 AD, we have leap years. Mind you, 100 AD is not a leap year because of the concept we discussed in one of the previous slides. 100 AD, not a leap year, or I would write it as normal year. So that means we have from 4 AD to 96 AD 24 leap years, and 100 minus 24 equal to 76 normal years. Therefore extra days is 76 into 1 plus 24 into 2, which gives me 124 extra days. But then it's not actually 124 extra days, it is 7 into 17, because equal to 119, that is 119 plus 5 gives us 124. So we have actually 5 extra days. A convenient way to find the extra days is just divide this by 7 and look at the remainder. So it is 7 ones are 7, so I write 1, 7, 5, 4 copied, then 7 sevens are 49, 5 is my remainder. So that means in 100 years we have 5 extra days. Okay. Next, let's move to what is the number of extra days in 400 years. So we found out that for 100 years we had 5 extra days. We found out here in the previous slide itself here. So for 100 years we have 5 extra days. So for 200 years we would have 5 into 2 equal to 10 extra days. 300 years we have 5 into 3 equal to 15 extra days. And 400 years we have 5 into 4 equal to 20 extra days. But hang on, since year 400 is a leap year, therefore since year 400 is a leap year, therefore one more extra day. Makes it 20 plus 1 equal to 21 extra days for 400 years. Applying the concept of rolling over, we get 3 extra days here for 200 years, 1 extra day for 300 years, and 0 extra days for 400 years. 0 extra days, that is from here, because 400 years had 21 extra days just now as we did. So now we can form our magic table, which is often used to solve the calendar problems. So this is how our magic table looks like. 100 years, number of extra days 5, 200 years, number of extra days 3, 300 years, number of extra days 1, 400 years, number of extra days 0. Once again, just to remind you, we are counting the years from the starts. 100 years is basically 100 AD. 200 years is 200 AD. 300 years is 300 AD and 400 years is 400 AD. So yes, now we are armed with all the knowledge to be able to solve our sample problem, which was this. What was the day of week on October 2nd, 1869? Let's check out. So since 400 years, we have 0 extra days. So 800 years also same thing, 0 extra days. Similarly for 1600 years as well, because 1600 is a multiple of 400. So till 1600 years, 0 extra days. Now 1800 years is 0 plus extra days for 200 years, which gives us 0 plus 3 extra days, going by that table, because 200 years is 3 extra days. So 1800 years, at the end of 1800 years, I have 3 extra days. So let me clean this slide for further calculation. Okay. So I will rewrite what we had. Till 1800 years, we had 3 extra days. Next, if we see, 1868 years have passed, and if we are calculating 1869, year 1869 is in progress. So let's see how many extra days for 1868. So for 1868, we have 3 extra days till 1800. For 68 years, let's see. Now 68 years, we would find out that there are 17 leap years and 51 normal years. This makes 17 into 2 plus 51 into 1, which is 85 extra days. And we had a carryover of 3 extra days, so total we have 88 extra days, which is 88 by 7. If I do normal division, I get 1718, then 2, 7 2 is 14, 4 as remainder. So 85 extra days is nothing but 4 days. So at the end of year 1868, we have 4 extra days. Let me clean the slide once again for further calculation. So till now we have found that 4 extra days till year 1868 end. So now I have to calculate total number of days from 1st January 1869 to 2nd October 1869. So if I see that, there are two ways of doing this. First thing is I can list down the number of days in each month, that is 31 days in January, 28 days in February since it's not a leap year, and keep on going till 30th of September, and then calculate 2 days in October. But I will rather apply a bit more intelligent way, that is this. Total days in year is equal to 365 because it's a normal year, and since I don't want to count from Jan till September, that is a long count, I will count reverse. I will count from December till October and then subtract the days from 365. So if I see December I have 31 days, November I have 30 days, and October I have 31 days, which gives me total of 92 days. So in that case I have 365 minus 92 equal to 273 days till September 30th. And 1st of October and 2nd of October, that is 2 days in October, so I have 273 plus 2 equal to 275 days till October 2nd. Now once again let me roll over 275 and see what I get. So 7 threes are 21, so 3, 21, 6, 65, 7 nines are is 63, so 2 as remainder. So I have got 2 more extra days. So let me once again clean this slide for a better view. So let me sum up. 4 extra days till 1868 end, and 2 extra days from 1st Jan 1869 to 2nd October 1869. So this gives me total 4 plus 2 equal to 6 extra days. And since initially I told you that we calculate with respect to a Sunday, therefore I will have 6 extra days with respect to Sunday, that will be a Saturday. That is 6th day with respect to Sunday will be a Saturday. So 2nd October 1869 was a Saturday. So that's how you solve the sample problems related to calendars. Let's move to one more sample problem which I am not going to solve myself but leave for you to solve. That is, how many times the 29th day of month occurs in 400 consecutive years. And here I am not talking about first 400 years but any span of 400 consecutive years. So I'm just writing down the answer for this. It should come out to be 4497. Just solve it for yourself and try to see if you get the answer. This question and few other practice questions you can find in a document whose link is given in the description of this video. I hope you enjoyed solving the calendar problems. Keep watching my videos. Thank you. Goodbye.